All right, so today I'm going to go over the API endpoint security that I implemented for the Calendly integration in Axiom Workspace. There's probably a lot of things that other people can benefit from this video because the concepts are the same um, for most applications. And I got all of my know-how on how to implement this through the Calendly documentation. So it might be beneficial to also see that at the same time as my video. But anyways, we can go right into it. So first, we have here like the route, um, and when setting up your app configuration with Calendly API, you can specify, the endpoint that you want Calendly to send notifications to. So this is part of the route. It will just tell Calendly API to send notifications to this method. All right. So from here, the first thing that we do here, the webhook handler first checks for the presence of the Calendly webhook signature in the HTTP request. So if it's not there, then it's not valid. It's not a valid. It's not a valid notification. So we must get that value. Once we get that value, the signature is extracted and validated. All right, so now the signature is extracted and validated using a method called getValid integration site, which we pass the signature and the raw body from the notification that Calendly sent to us. The way that we validate the notification, we're going to go through that right now. So here in the method called parse signature, it splits the signature that was given to us from Calendly into its components. So we retrieve the timestamp and the signature from this. And then from there, let's go back. Oh yeah, I would like to say that this is the format in which signatures are in Calendly. There's like a T equals and then timestamp after it, and then the signature is like a V1 equals and then the signature. That's the way that Calendly sends it. So now if these two values are null or empty, then we can say that this is not a correct notification. It cannot come from Calendly. All right, next we go through all of essentially the accounts that users created in Axiom Workspace, and then we must verify that they are Calendly accounts. And then what we do is, in the process of that, we are decrypting the API key for that account. And this is because we actually securely save the API key in our database. That's why we need to decrypt it. And our application securely manages API keys by encrypting them before storage. It also uses a unique salt for each API key, ensuring that even if two keys are the same, uh, their encrypted versions will be different. And normally these keys shouldn't be the same. Then we also append a master password to also add more security before decryption. So this is all done in this method. So this gets the decrypted accounts basically. Now we get this decrypted key and we call generate signature. We're going to use a decrypted API key, which is essentially a value that is shared with Calendly, which we created, which is shared with Calendly to for them when they send each notification. It will be like the signature will be wrapped or will be signed with this API key that we specify. So we create this API key using a GUID to basically generate a type of ID for each account in our application to make it unique. And then we share this when we're creating the Calendly subscription for this user's account. We share this this ID, this API key with Calendly. So then now when they send notifications to our application, it's signed. It's signed. If I had explained signed, think about it as something being wrapped with a key, with only something that the key can open. So basically that's what we're gonna do. We're gonna use this key. We're gonna generate an expected signature. All right. So we got here. This method basically creates a HMAC, with the SHA-256 signature using the raw body and as well as the timestamp, and we put it in one string. And the raw body of the request and the signing key right here. This is actually the same thing as the decrypted API key. All right, so and also the timestamp, the fact that like a timestamp is unique, it also creates makes this string unique because this raw body could be replicated, but then this timestamp is unique. So putting it together when we then hash it will make it so that this hash is very, very unique and hard to forge. So the concatenation is basically what I was describing. It verifies, it helps verify like the integrity and the authenticity, and the authenticity of the webhook data sent by Calendly or sent to our notification or our endpoint. So now we're gonna basically rehash it to generate this signature, and then this is basically the expected signature. So if Calendly sends the correct notification, their signature that we already parsed and all that kind of stuff should be the same as this one that we just generated using the user's API key. If they're not the same, then this notification is not for that account. And if we go through all the accounts in our database and we cannot find the signature that was sent to us, and if it doesn't um, match the expected signature, that means that this is a fake um, notification. That's like a hacker that a hacker made basically. Anyways, you go here, signature or secure compare. So this secure compare, it is a method that is resistant against timing attacks. During string comparison, using this like library in the .NET. Uh, so you know if a eavesdropper or someone who's malicious is like monitoring all of the ins and outs of notifications, and they're timing it using different algorithms and softwares. They can, if there was just a simple equals, uh, like a simple string comparison, they could actually be able to figure out what the expected hash is supposed to be, which then they can like forge um, these signatures to then get get by and manipulate uh, data that would be sent into the application. But by employing this right here, it makes it so that every single time we do a string comparison, it's gonna always um, finish the process of string comparison at the same time, which means that the person can't do any timing attacks. So now, once we figured out that the expected signature and the one from the Calendly notification is the same, and then we can be sure that this is indeed from Calendly, and also through the process we're able to uh, authenticate this notification and figure out who is it for, which makes it now easy uh, to return the site, or basically the the account that it's for. So then we can start parsing the payload, all the data meant to be sent. So like everything about the event, who's it for. We can now use this data that was sent, and we can use the user account. We can start, updating the data in our database so that it can be used for the user. And yeah, so the reason why we deserialize here, the raw body is in a JSON format. So we got to deserialize it, and we got to turn it into an object that we can use, basically. So that's just the whole point. And for C# specifically, something that we use is here JSON property. So like the JSON would have like a name of event, and then it would be like a string value. So then this basically maps that JSON to this value in this object. So this is kind of the way it works, because we have like a certain naming schema. We don't want to like name our variable created at with a underscore. So this is basically the way we can map from JSON to an object that we create. So then we can just parse and parse this data and format it the way we want in our database to then be able to use it. All right. That's it. Thank you.